From the previous episode, we defined force as a push or pull. We learned about Newton's 3 law of motion and how force plays an important role on them. Let's take it in a real-life situation. Have you tried riding a bicycle? Were you able to balance it? Like this? Did you know that when you are riding a bicycle, more than one force is acting on you and the bike? What do you think were those forces? What are the types of contact and non-contact forces? How do they work on object? To answer this question, let us explore how a body responds to change in motion. There are a variety of types of contact and non-contact forces. Gravity is one of the many types of non-contact forces that pulls all object toward the center of the earth. Everything we throw something up, gravity constantly pulls it down. Let us try these experiments. Hang the pen using this string. And place the base on the table. What makes the pen and the base at rest? That's right! The pen stays in place because of another force that acts on it that is supplied by the string, which we refer in physics as tension force. Tension force is the force which is transmitted through the string, rope, or wire when it is pulled tight by forces acting at each other. The base, on the other hand, stays at rest because of the upward push exerted on it by the table, which is referred to as normal force. Normal force is the support force exerted upon an object that is in contact with another stable object. Both the tension and normal forces counteract the pull of gravity that acts on the objects. These forces cancel out with each other that allows them to stay at rest. In both cases, you can infer that an object remained at rest because the forces acting on the pen and on the base are equal in magnitude and in opposite direction, and they lie along the same line of action. The forces are said to be balanced. What are balanced forces? Balanced forces are forces that are equal in magnitude and in opposite direction, so there will be no motion in an object. Now, let us cut the string. What happened to the pen? That's right, it fell because there is no force acting on the pen to counteract the pull of gravity. How about if I push this base sideward? What happened? Did it continuously move? That's right. The base moves, but it does not continuously move unless I continuously push it. The base moves because of the applied force. So, the force acting on this object are no longer balanced, or it is said to be unbalanced. What is unbalanced force? Unbalanced force changes the motion of an object. This happens in two ways. If an object is at rest and an unbalanced force pushes or pulls an object, it will move. Unbalanced force can also change the speed or the direction of an object that is already in motion. A force has a magnitude and direction, and they are equally important. From our previous experiments on the hanging pen and on the base on top of the table, we can say that there are balanced forces. Balanced forces can cancel out each other. Anytime there is a balanced force, object does not move. When two forces of the same magnitude but act in opposite direction, they are called balanced forces. On the other hand, if an object initially at rest is under an unbalanced force, it moves in the direction of the force with greater magnitude. A perfect example is the game tug of war. If the people on each side of the rope are pulling with the same magnitude but in the opposite direction, the forces are balanced. There will be no winner since the opposite forces cancel out. But if the players on one side of the rope use greater forces than the other side, they will fall backward because it experienced an unbalanced force and eventually winning the game. For you to determine the net force or unbalanced force, you must recognize those forces that act along the same line of action. The algebraic sign, positive and negative, are used to indicate the direction of forces. Remember your lesson in mathematics about the coordinate system? Unlike signs are used for forces acting in opposite directions. Like in the case of the ball lying on the top of the table, the gravitational force and normal force are assigned with opposite sign representing the positive y and negative y axis. Normal force is given positive sign while gravitational force is given negative sign. If both normal force and gravitational force are given a magnitude value of 5 units, then the net force along the line will be 0. Let's go back again in our previous experiment. The base on top of the table can be understood easily using free body diagram. For instance, the base stays at rest because it has a normal force of 5 newtons and gravitational force of 5 newtons as well. Let's find out the resulting net force on the base. If the sum of the force equates or equal to 0, the forces are considered balanced. If the algebraic sum is not equal to 0, the forces are not balanced. The non-zero sum is the net or unbalanced force. This unbalanced or net force could cause a change in the body's state of motion. However, there is another force that acts on the ball along the horizontal line or along the force that makes the ball in motion. This is called friction force. Friction is a force that acts between surfaces that are in contact with one another. Friction in general acts opposite the direction of the motion. In the case of the rolling ball, the friction force acts between the surface of the ball and the table and slows down the motion of the ball. As the ball rolls to the left, friction acts to the right to delay its motion. Since no one will push the ball continuously, there is no force present to balance the force of friction. So the ball slows down and eventually stops. Again, because of the unbalanced force, the object changes its state of motion, so you can say that it accelerates. Take note of this. Acceleration is not just an increase in velocity, but also a decrease in velocity or change in direction. So the acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the net force increases, the object's acceleration increases too. So if you push twice as hard, it accelerates twice as much. Now, let us apply what you have learned for this lesson. For learning task number 1, identify the situation if it shows balanced or unbalanced force. Write your answer in your notebook. For learning task number 2, study the diagram above. Answer the guide question. For learning task number 3, examine the picture below. Tell whether there is balanced or unbalanced force in each situation. For learning task number 4, try to solve this problem about balanced and unbalanced forces using Gressa method. Write your answer in a separate sheet of paper. For your learning task number 5, choose the letter of the correct answer. Write your answer on a separate sheet of paper. Please do not forget to subscribe to our YouTube channel, Math Cycle. Like the videos and hit the bell button for updates. I hope you learned today's lesson. On the next episode, we will be focusing on the factors affecting the potential and kinetic energies. This is Ma'am Catherine Fidelino, your science teacher. See you all next time!